Question 748. Let A be the base of a solid enclosed by the graphs of f and g as shown above, and the cross-section of the solid taken perpendicular to the x-axis is an equilateral triangle. Write but do not evaluate an expression involving one or more integrals that gives the volume of the solid. Alright, we have a figure right over here, and we have two functions f and g, right? Remember, if the cross-section of the solid taken perpendicular to the x-axis, then our volume is integral dx, right? We have to write the area in terms of x, right? Area here. Okay, our cross-section here is equilateral triangle, right? So from 0 to 0.2 up to this value, 0.2, this is our side of the equilateral triangle, right? We have equilateral triangle like this. And I'm gonna say the side of the equilateral triangle is S. Okay, so from 0 to 0.2, our S is y of this curve, function f of x, right? So that's going to be equal to e to the x, right? From 0.2 to 1/2, our side of the equilateral triangle is y of this function right here, right? Function g. So we have equilateral triangle like this. Okay, so I'm gonna let this one is another s. Okay, that s is equal to y of this curve, and that is equal to negative 4x plus 2, right? Now let's write the volume here. So from 0 to 0.2, we must write the area of equilateral triangle, right? The formula for the area of equilateral triangle is root 3 over 4 side square, right? From geometry, okay? Plus from 0.2 to 1/2, root 3 over 4 side square again. But remember, this side and this side, they are different sides, right? The s from on the left integral, that's this, right? The s on the right integral, that's this side, right? So that is equal to root 3 over 4 integral from 0 to 0.2 s squared. This s squared, right? We have to write in terms of x. So e to the x squared dx plus 0.2 to 1/2. Well, let me write root 3 over 4 right here. And s squared, this time s is this, right? So negative 4x plus 2 squared dx, right? That's our volume here, right? Question 749. Let A be the base of a solid enclosed by the graphs of f and g as shown above. Each cross-section of the solid taken perpendicular to the y-axis is a semicircle having the diameter in A. Write but do not evaluate an expression involving one or more integrals that gives the volume of the solid. Alright, we have function f and g, right? And this time, the cross-section of the solid taken perpendicular to the y-axis is a semicircle, right? If we have cross-section perpendicular to the y-axis, then our volume is a definite integral dy, right? And here we must have area of semicircle in terms of y, right? Now let's draw our cross section perpendicular to the y-axis. So from here to here, our diameter is from here to here, right? That's our diameter. So our cross section looks like it's a semicircle, like that, right? And from here, 1, 2, up to this point, our cross section looks like that, right? Here's another diameter, and another semicircle, and diameter is from here to here, right? This diameter right here, let's say diameter is d, okay? D is equal to the distance from here to here, all the way to here. That's a 2, right? 2 minus x of this curve, this line, right? So that's going to be 2 minus x, and that x is in terms of y. Here we have line y is equal to 1 minus x. So x is equal to what? 1 minus y, right? So we can write 2 minus x, which is 1 minus y. So that is equal to, if we simplify this, that's going to be 1 plus y, right? Now let's find this diameter right here. This diameter is 2 minus x of this curve, right? So 2 minus x, and that x is equal to, here the curve is y is equal to e to the 2x. So natural log y is equal to 2x. Then x is natural log y over 2, right? So that x is natural log y over 2. So far so good? Okay, we have to find the area of semicircle, right? The cross-section semicircle. Here, if we have semicircle with the diameter d, see here's the d, we know that area of the semicircle is 1/2 times pi r squared, right? The area of the circle, pi r squared. And in terms of d, in terms of diameter, r is equal to d over 2, right? So that's going to be pi over 8 d squared, right? So our volume is equal to, from -1 to 1, from -1 to 1, pi over 8 d squared. Let me write d squared first. And dy, right? That's our area, and we must have a dy here, right? Plus, from 1 to, when x is 2, if we substitute 2 here, that's going to be e to the 4, right? Y is e to the power over 4. So from 1 to e to the 4, pi over 8 d squared dy, right? So we must write this d in terms of y, right? So that is equal to pi over 8, integral from -1 to 1. Okay, d squared. The first d is right over here, 1 plus y, right? So that's going to be 1 plus y squared dy, plus another pi over 8 times integral 1 to 4. Here, this d is right over here, 2 minus natural log y over 2, right? So 2 minus natural log y over 2 squared, d squared, right? dy. So this is our volume, right? Question 750. This time, each cross-section of the solid taken perpendicular to the x-axis is a rectangle whose width lies in A and height is twice as long as its width. Write but do not evaluate an expression involving one or more integrals that gives the volume of the solid. Alright, for this problem, our cross-section is perpendicular to the x-axis, right? So we must have volume is equal to area times dx, and the cross-section is a rectangle whose width lies in A and height is twice as long as its width, so 2 times width, right? So let's draw one cross-section that is perpendicular to the x-axis. Okay, this is our width, and our rectangle looks like that, right? So this is our width. Let's say this is S, and then our height of the rectangle is 2 times its width, 2s, right? The area of this rectangle is, here's s, here's 2s, so area is just the 2s squared, right? And we have to write s in terms of x, right? And s is just the upper curve minus lower curve, right? So fx minus gx, f of x minus g of x. In terms of x, that's e to the 2x minus 1 minus x. So that is e to the 2x plus x minus 1, right? So we're almost done. Our volume is equal to, from the interval of x is from 0 to 2, right? From 0 to 2, the area of the rectangle, that's 2s squared. So 2 times s is e to the 2x plus x minus 1 square dx, right? Question 755. Let A be the base of a solid enclosed by the graphs of the function y is equal to 4 minus x squared and y is equal to root x plus 2 as shown above. The cross-sections of the solid taken perpendicular to the x-axis are isosceles right triangles having the one of the legs in A. Write but do not evaluate an expression involving one or more integrals that gives the volume of the solid. Okay, so we have cross-sections perpendicular to the x-axis, right? So the volume must be equal to definite integral with the dx, and we must have area of isosceles triangle. It's isosceles right triangle, right? Having one of the legs in A. So if we draw one cross section, then that's gonna be like that, right? This is isosceles right triangle, like that. Okay, and this is our hypotenuse, right? So let's say this is our S, side S, and S is just the upper curve minus lower curve, right? This is our upper curve, lower curve, right? That's gonna be 4 minus x squared minus square root of x plus 2. So if we simplify this, that's gonna be negative x squared minus the square root of x. 4 minus 2, that's plus 2, right? So our volume is equal to integral from here is 0, right? This value is equal to 1. So from 0 to 1, area of this isosceles right triangle, that's going to be, area is equal to 1/2 times base times height, right? Here's the S, here's also S. It's isosceles triangle. So that's going to be equal to 1/2 s squared. So 1/2 s squared dx, and we have to write this s in terms of x. So that's going to be 1/2 times definite integral from 0 to 1. S is right over here. So that's going to be negative x squared plus, it's minus square root of x plus 2 square dx, right? That's our volume.